Hello and welcome back to Little More Learning. In this video, we will be studying about data visualization using Python. Before moving further, we should understand what data visualization is. So, data visualization is the graphical representation of information and data. By using visual elements like we have charts, or we can say we have graphs, maps. So, why we use data visualization? Firstly, it simplifies complex data. What it means? It makes large data sets easier to understand. After all, when you see a pictorial representation of a data instead of the entire data set, it becomes much easier to understand that. So, when the stakeholders can quickly grasp the insights of the data, they can make quick decisions. And when you have a picture of your data, you can just convey the story behind that data very effectively to anyone you are explaining it. Then, before moving to the libraries, we should know what types of charts we are having. We have line charts, we have bar charts, histograms, and lastly, we have scatter. We will work upon all these four types of chart on these three libraries in Python used for data visualization. Basically, Matplotlib and Seaborn are the most frequently used libraries in Python for data visualization, whereas Plotly is quite optional. Matplotlib is a versatile library for basic and custom visualization. So you can understand it as the very basic step of data visualization in Python. So from here, let us move on towards the Google Colab notebook where we can run the Python code and you can better understand about Matplotlib. All the code snippets here are along with their output so that you can understand them better. From these lines of code, a line chart with months on the x-axis and sales on the y-axis showing an upward trend, and this plt.grid statement adds a grid for better readability. Now, the output for these lines of code will be like this. Sales on the y-axis, months on the x-axis, and the graph and a line chart is plotted for them. The next code is for a bar chart that will compare the sales of different product categories. So, the plt.bar statement creates a bar chart and the parameters such as categories add categories on the x-axis. Sales is the height of the bars or the sales value, and the chart shows which category generates the most revenue. So from these line of code, we can expect a vertical bar chart comparing the sales of different categories. So here you can see a bar chart comparing the sales of electronics, clothing, and home appliance category. The next line of codes are for a histogram, and it helps to visualize the distribution of employee salaries. So the plt.hist creates a histogram. The parameter bins specifies the number of intervals. For example, here it is 5. The color sets the color of the bars to green. You can change it to any color you want. The edge color adds border to the bars for better clarity. And from these lines of code, we can expect a histogram showing how employee salaries are distributed across different ranges. So here you can see how the salary of an employee and the frequency of them are distributed. Now, the next line of codes are for a scatter plot. We will plot a scatter chart to examine the relationship between employee age and their salaries. So the plt.scatter plots individual data points in our scatter chart, and it is useful for identifying correlations. Like, for example, older employee earning higher salaries. So, from these line of codes, we can expect a scatter plot where each point represents an employee's age and corresponding salary. From this scatter plot, it is clear that our employee of age 25 has a salary of around 40,000 and an employee of age 45 has a salary of around 80,000. More the age, more the salary. Discuss about Seaborn now. So Seaborn is a Python data visualization library built on the top of Matplotlib. It provides a higher level interface for creating attractive and informative statistical graphs. So why we use Seaborn? Firstly, in the current generation, aesthetics are the most important thing. So Seaborn provides us aesthetics. Then it has much simplified text. Lastly, statistical insights. As built-in support for adding trends, distributions, and summaries is there in Seaborn. So it helps us in getting better statistical insights out of our data. So back to our Jupyter notebook. Now, firstly, if we are not working on Google Colab or you're working on your own desktop in VS Code or any other code editor and you have Python installed, then you have to install C1 into your system to let it work. So the pip command helps us in installing the library C1 into our system. Since we are using Google Colab, we do not need to do any kind of installation. Next is the code of a histogram with kernel density estimation or KDE using Seaborn. So the SNS.histplot combines a histogram with an optional KDE curve to visualize the distribution better, where KDE equals true adds a smooth density estimation curve over the histogram, and the bins are the number of intervals for the histogram. So, as you can see in the output, the histogram is created, and we also see a curve to analyze better about the data and the insights that we can derive from this histogram and the curve along with it. So, the next code is for box plots, and these are used for identifying outliers and understanding the data spread. So, firstly, outliers. Outliers are the data points outside the normal data range that indicate anomalies. So, from this, we can see statistical insights also by just moving our cursor to the boxes that are plotted on this graph. The next code deals with scatter plot with regression line. So in this, we will just visualize the relationship between employee age and salary. SNS.regplot combines a scatter plot with a regression line to show the trends. And from here, we can see a scatter plot, which much looks like a line chart, but actually it is not. It is having a regression line and markers to point on the graph. Then next we have statistical summary visualization, and we will be doing it using heat map. And heat maps are excellent for visualizing relationship between numerical variables. So here, df.corr computes the correlation between matrix and numerical columns. And SNS.heatmap displays the correlation as a heat map and not equals true as numerical correlation values to each cell. The output is obtained something like this. Moving on to pair plot, the first line of code loads the built-in iris dataset, and SNS.pairplot creates a scatter plot for all pairwise combinations of numeric columns. And hue differentiates data points based on categories, for example, species. Something like this for sepal length, sepal width, and petal length and petal width, we can obtain the data. So here only we will discuss about Plotly. So Plotly is a powerful library for creating interactive web-based visualizations. And unlike Matplotlib and Seaborn, Plotly charts are interactive by default, enabling zooming, panning, and tooltips for deeper exploration. Like it is the most advanced library for data visualization in Python. So why we should use this? Because it is interactive, web ready, and there are wide range of visualization options present in Plotly. Again, like Seaborn, we had to install it into our system and import it. After that, the first set of our code is of interactive line chart, where we will plot monthly sales as an interactive line chart. Now, the output here. You can hover on and you can see the month and the sales for each of the month here. Next is for an interactive bar chart that visualize sales by category interactively. So when you are hovering upon these bars, you can see very well that the product category and the sale associated with it is given. Bars are color coded for clarity, and hover reveals the category and sales value efficiently. Then is a scatter plot with interactive features that explores age versus salary relationship with tooltips. So, the tooltips here show detailed information for each data point, and bubble sizes corresponds to salary amount. As you can see, the salary of 40,000 has a smaller bubble than the salary of 80,000 that has a larger bubble. Then we have a choropleth map that visualizes sales by region on a world map. Now, this might be something interesting for you. Like when you are hovering on any country, it shows the country and sales. Like Germany, India, United States we have. Then again, it is a part of United States. You can zoom in and zoom out into this map. That's how it works. Now let's discuss best practices for effective visualization. So firstly, you should understand your audience well. You can tailor your visuals to your audience need. Like if you have executives as your audience, so focus on high level insights. Or if you have analysts, so provide detailed data. Keep it simple. Avoid clutter and minimal text and labels into your visualization charts. Now, the most important thing is choose the right chart. How can you know which chart will be the best suited for your data? Now, let's see. If we have a bar chart, bar charts are used for what? Comparisons. Then we have line chart. Line charts are used to explain trends over time. Then we have scatter plot. Scatter plots are used to visualize relationships between variables. Then histograms. Histograms are used for data distribution. Lastly, heat map. When you will use heat map, when you have to show correlation or intensity, then you will use heat map. Next is use colors wisely, like use consistent color schemes and avoid excessive or clashing colors. Next is add context. Always add titles to your chart. That is most important thing. And clear labels and data points are also a plus point while visualizing your data and presenting it to someone like executives or analysts or the stakeholders. Accessibility is an important part of effective visualization. Last one is test your visualization. Ensure that your audience can interpret the insights without any confusion. Gather feedback to refine your charts for the next time. So, that's it for this video on data visualization. using Python libraries such as matplotlib, seaborn, and Kotlin. And in the next video, we will look at advanced data analytics with Python using the scikit-learn library. See you in the next video. Till then, happy learning.